Welcome to Olympian Water Testing, giving you the best in water analysis. Today we're looking at cadmiums in soil and groundwater, and CD is a non-essential trace element that is distributed in the environment. Both geogenic and anthropogenic sources can elevate CD concentrations in soils and groundwater, which are important for maintaining healthy supplies of food and safe drinking water. Elevated CD doses are carcinogenic to humans as well, and that comes from our heavy industry, things like fertilizers, and CD sources include mining, atmospheric deposition of combustion emissions, and the use of CD-containing fertilizers. And they're taking a look at cases of CD pollution in soil and groundwater based on worldwide accounts. Besides anthropogenic CD sources, it's also incorporated in sulfates, carbonates, phosphorates, resulting in elevated CD concentrations in associated rock types. So what did they find? As we know, it's one of the most toxic and mobile elements in the environment, and it can replace calcium in minerals, and it's similar to ionic radius, identical charge, and similar to chemical behavior. Also, chronic CD poisoning, and termed IT disease, was first discovered in Japan in the early 20th century, caused by renal tubular dysfunction, osteomalacia, and osteoporosis due to a competition with Ca and other nutrients. And it's also associated to glucose metabolism disorders, breast, lung cancer, cerebral infarction, and cardiac failure. So it can cause a lot of issues, even in your liver and kidneys. The focus of different studies was the examination of chemical reactions and the transport behavior of CD stemming from its complex interactions in aquatic systems. And on the general hydrochemical behavior of CD, it exists a lack of general knowledge about CD sources, its geochemical behavior, as a role as a competitor with other heavy metals, resulting in CD concentrations in groundwater, and it's particularly evident compared to the well-investigated toxic elements, as we can see here, that it can cause a lot of issues. As we can see, cadmium content in soil and groundwater right here. And we can see the median pH, and we can see what's going on here. And these are cadmium concentrations in groundwater related to stratigraph and petrograph aquifer features. And the bars represent the 50th percentile lower edge and the 90th percentile upper edge of CD in groundwater. Red bars show limestone-dominated aquifers, blue bars show miscellaneous aquifer material, and aquifer order indicates median pH in groundwater from acidic left and alkaline right. For the interpretation of references to color in the figure legend, the reader is referred right here. So we can take a look and see what it's doing. Cadmium in the 90th percentile as background levels we can see in groundwater in the Paleozoic, Triassic, and Jurassic aquifers, Cretaceous and Cenozoic aquifers as well. Apart from the calcium carbonate, centrifugal aquifers, limestone-dominated aquifers had low CD concentrations in groundwater. Most of them belong to aquifer systems with alkaline conditions. So we're taking a look at different types of aquifers in Pakistan to understand how this works. And as we can see, this is really causing issues for groundwater. And in northern Germany, a variation of CD concentrations from 2 Plectozoan glavis flow sediments to 20 UG in the Hausolinic sands covered by marsh sediments and reported for the road traffic influenced soil water and groundwater. So as you can see, this is an issue everywhere. And definitely cadmium getting into soils and groundwater is going to have a bad effect, especially once it gets in groundwater. And if you have a lot of groundwater around you, this is something that you might want to look into, especially in the age of heavy industry. That's why it's always a good idea to periodically test your water for high levels of cadmium.